I thought it was about time I did an update video on the 12-channel servo controller we do. So I grabbed a servo controller, brought it up to the camera and thought, hang on a minute, there's an awful lot going on here. We've been steadily busy for the last couple of years tweaking the software here and there, and we've released a number of updates. And so when I researched, would you believe, there are over 30 features on this servo controller, 30 individual features that can be demonstrated. So I had to write them down. Here they all are. So I'm hoping to show you everything this little guy can do in one single video. After looking at all the features, I have to conclude that this is probably the most powerful and sophisticated servo controller on the market I've ever come across. Straight out of a box with a warranty from the manufacturer. Plug it in, hook it up, and away you go. So let's just run through some of the features I'm going to show you in the first part. First of all, we can configure it without the need for any additional programming devices. All you need is a finger or a thumb, press a button, and you can set any feature up on this board that the board has to offer. It can run either completely standalone with toggle switches, or you can network it. It can support integrated frog polarity switching, or if you use install frogs, then that's an add-on you don't need to buy and you can just use it as a bare board. It has multiple nodes for each of the outputs, which are individually switchable, including switching turnouts or points, semaphores, whether they're upper or lower quadrant, and you can even vary the speed on a per channel basis for gates, barriers, doors, decouplers, and etc. The board even has route programming on board, so you can set up 3 routes straight out of the box without having to connect it to anything else, and I'll run you through that shortly as well. It does optionally support remote setup, so if you've happened to have fitted this board under your baseboard and you can't get to it, then don't worry, we've got you covered there with the remote setup connector, and I'll demonstrate that to you. And of course, for the power, you give it 12 volts from a regulated power source, and it's polarity independent, so we don't care what the polarity is. So okay, let's get the show on the road. First thing I'm going to do is hook up some power. And we'll turn the board on. Turn the power on, and the first thing you notice, it has a flashing LED. That's the heartbeat, and it's telling you that the board is working. Before I dive in too deep, understand that everything I'm about to tell you can be found in the user guide for this. It's available online from the shop product page. You can just download it freely, and it'll walk you through the new features, some of the old features, what you get in the box. It'll explain how to hook it up with pictures, how the various switches and buttons work, and most importantly, there's a reference section as well that shows you how to configure all of the modes I'm going to show you on this today. So it's all in here, so you don't have to remember it. Everything's in the user guide, which you can get from the shop page. Just download it, it's a free download. So I have the servo controller working, it has some power in, and you can see the flashing heartbeat LED. Let's take a servo. Here's a typical servo. These are a 9-gram servo. They're currently costing about £1.70 something in the UK. Servos have sockets on, so you just plug it in. So if I plug it into channel 1, here's my servo connected. And all I need to do to operate it is short one of the S1 to S12 inputs to the ground connector at the bottom, which is labelled SC. So if I touch this connector and this connector, servo moves. Release it, it moves back. It really is that simple. If I want to be fancy, here's a toggle switch. So I'll take the black center pin onto the switch common, and let's put the white lead onto switch 1, S1 input. And now when I operate my toggle switch, the servo moves. How simple is that to wire up? Like all good videos, here's one I prepared earlier. It's hooked up with 12 servos across the top, 12 switches here, and a number of other things all dialed in. So when I turn this on, you can see that the servo controller operates 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's all of the servos moved, and now they've gone totally silent. Let's move them all back. So I've just demonstrated using 12 switches with 12 servos. Switches connect here, servos plug in here, and you can see all 12 of them moving. Let's say that when I operate switch number 5, can you see it's moving to the right when it's up, and the one next to it moves to form a cross? Say they're opposing points on a crossover, and I want to reverse this one. So here's a feature coming on. What I'm going to do is reverse this one, which happens to be on channel number 5. 1, 2, 3, 4, 5. How easy is this? We press the program button 5 times. 1, 2, 3, 4, 5. I'm on channel 5 because the last servo that moved is on channel 5, and those lights are flashing in what might appear to be a peculiar pattern, but they're actually telling us something. If I cover this one over to make that one easier, you'll see it's flashing 5 times. 1, 2, 3, 4, 5. It's telling me the unit's now programming channel number 5. And this one on the right, the mode, is telling me that channel 5 is currently configured to mode 1. And modes 1 and 2 are for points use, and they'll move. Mode 1 is normal and mode 2 is in reversed. So what I'm going to do to move this channel from mode 1 to mode 2 is press the mode button once. Now you'll see the mode button is flashing twice. It's in mode 2. So let's carry on pressing the programming button until I finish on 12. So it's currently on 5, 6, 7, 8, 9, 10, 11, 12 and out. Now the unit's working fine, but look at this guy. It's now running backwards. Remember before they came like this? It's moving in the reverse manner to all the others. So you can see there I've just reversed this or changed its mode using only a finger. No fancy add-on tools whatsoever. Now you can see this channel number 1, I would say, is a wannabe semaphore signal. It's sort of not quite right. So what I'm going to do is I'm going to configure that for an upper quadrant semaphore. Here we go. So I will go press the program button once for channel 1. I'll select mode number 3. So it's already on 1. So I'll go 2, 3. And now you can see the mode light is flashing 3 times. 1, 2, 3. What I'm going to do now is I'm going to teach it precisely how far I want this to move. So I'm going to press either the low or the high button. Let's start with the high, and I'll bring it down till it's parallel, about there. Now I'll press the low button and take it until it's about 45 degrees. So I've now moved it manually from one range of motion to the other. I've set that motion. If I hold the program button down, it'll scoot through the other 11 and return to run. Now when I flick the switch for channel 1, you can see it's moving and it has a random bounce attached to it. Even the pull off is randomized. See, we slipped a little bit there where the signalman pulled the lever halfway, stopped and then finished the pull as he took the slack. As I release this, see, the bounce was quite different then. There are 1,500 different bounces modelled in this, so I've no control, it'll just randomly bounce. And even the pull off and dwell is randomized as well. As I pull the lever down, the semaphore comes down. As I push it up, it goes to clear. That's your upper quadrant semaphore. Let's say this is now a lower quadrant. So I'll go into program, and you can see I'm on channel 1, one flash, and it's in mode 3. And we want mode 4. So I'm just going to press the mode button one more time. And now I've configured it for mode 4. And now when I release it, it seems really weird because the bounce is at the top and the pull off is to the bottom. And the reason for that, it's now a lower quadrant semaphore. So if I pull the signal arm off and reattach it in about the right position, you'll see now it's operating as a lower quadrant. Can you see it's not quite parallel, is it, to the ground? So That would annoy me. So let's fix it. I'll just press the program button once because I want to program channel 1. And now using a combination of the low and high buttons, I will program for 45 degrees and parallel to the ground the range of motion. Skip through the other 11. If you go too far with the programming, turn the power off and on. It's a faster way to do it really, but for demonstration I prefer not to. There you go. Now I've got a lower quadrant semaphore working. So we're rattling through the different modes. We haven't broken out a sweat and we haven't used any tools yet. What I'm going to do now is change the speed of some of these. So let's change the speed for channel 1, 2, 3, 5, 7. So I'm going to change the speeds of channel 3, 5 and 7 and let you see that. Program 1, 2, 3, 4, 5, 6, 7. Now keep your eye on these, see how they're moving differently. This guy's in a hurry, this guy's going nice and slow like it might be for a gate, a barrier or a door. So what I've done is using these memory buttons which double up as the speed control, I can vary the output speed of any of the channels, in this case these 3. Okay, let me show you how the memories work, and the memories are configured using these buttons here. So let's assume I have a crossover approaching a regional station and I want to move the crossover so that the train can cross the tracks. So let's say that's attached to channel 2 and channel 3. Then I want to clear it with a semaphore. So I've now operated 3 switches, and once the train's gone through the crossover there's a couple of points at the back, so let's do 9 and 10 to get the train onto the right platform. Now if that's a regular manoeuvre, you can see there I've had to operate 5 switches. Instead, if I just press one of the memory buttons, I'm using this one, if I press and hold, watch for the red light. See the red light flash? That's now been stored as a configuration in one of the memories, in this case memory 1. So now instead of pressing all the buttons to recreate that manoeuvre, I press the memory. Points come to clear, the semaphore comes to clear, the points move to their predetermined positions. And this unit on its own has 1, 2, 3 memories. And if you look, this unit's so powerful it can move all of the servos at the same time. Imagine that you have a rhombus fiddle yard like this, and when you operate this point here to set this road in, you want to also set the corresponding road out at the same time. Instead of wiring switches to each, this has a simple method of doing it. So let's assume I put one servo controller covering this side of the fiddle yard, and I don't know, 30 feet later I have another servo controller on this side of the fiddle yard. So here's a pair of servo controllers. I have the master on the left, flick a switch, everything works, and here I've got no switches because nothing is connected. So I'm going to configure this to be a slave device. Turn the power off, hold the low button down, turn it on. Look at the lights flashing, you get an alternate flash. That's to tell you it's a slave device. Every time I turn that on now, it's a slave device. So if I take your typical servo lead and I plug one end here and one end here, you'll see now that as I operate switches here, it's now controlling these as well. A lot of motors moving there. Look, I can move all 24 in one go if I wish by recalling the memory. And they go silent and back. So if I have this board on this side of the fiddle yard and this board on this side of the fiddle yard, all my control wiring comes down to this one cable. How simple is that? That's the master-slave configuration, and this servo controller does it straight out of the box. Now what I've just shown you there is some of the advanced features of this device. For example, here we've configured the network by just plugging the cable in and telling this board it's a slave. And this enables some quite powerful possibilities with this system. For this next part, we're going to talk about some of the network features that this board has built in. So I've widened the shot, moved a pair of controllers further back, and I have 24 servos connected and the two boards connected to each other like they were in the last video. This time I'm going to introduce a mimic panel. So yes, we do make mimic panels. Here's one of my demonstration units, and what you'll find on the back is there's a little connector for an extension cable. I've fitted one here and I also have one here. So if I take this cable and plug it in, I can now introduce this mimic panel to the rest of this network simply by plugging it in, and it doesn't matter whether I plug it in on this board or this board. Let's plug it in on this one. And when I turn it on, where's the power switch? There it is. The lights will flash and the servos have immediately moved to where they're commanded to by the panel. So as I press a button, you can see the lights flash, the servos respond immediately. Here's the first 12, here's the second 12. This particular crossover has one servo on this controller and one servo on that controller. But all these features are standard on this servo controller. You might say, well, Dave, I'd like to control this from my DCC handset, not from a mimic panel. Nothing could be easier. If I take the mimic panel away, let's take this other servo controller away for now as well. And back to the same servo controller we started with. I'm now going to add a DCC module. That's this little board here. Here's my DCC system. I'm using an NCE power cab, but it works with them all. Here's my track pickup for the signal. So if I drop that down, all I have to do is plug it into the DCC module, turn on the track, let's get a DCC signal, and now the servos are moving to the last commanded position of the DCC controller. And as I fire accessories, let's move number 1 and back. Let's run a macro. Now I'm moving them all and all back. So I also have full control through my DCC handset. You might say, but Dave, what about frog polarity switching with servos? I've heard it's difficult to do. Tosh. All you do is you add one of our relay driver modules. Here it's configured for 12 relays, perfect mating with a 12-channel servo controller. Take that same network lead, plug it in, and you're now connected through that one cable to 12 relays, and each relay is capable of switching 10 amps. Flicker switch. How easy is that? Flicker switch and the corresponding relay moves. If I run the memory, there's all 12 on. What could be easier than that? It's so straightforward and easily expandable. There'll be some of you out there going, yeah, you're showing individual features. What about if I want frog relay switching and my DCC controller or what else on the network? Okay, let's give it a go. Here's my DCC module coming back. Let's squeeze it into the frame here. What I'm going to do now, instead of operating this from switches, I'm going to tell it it's a slave device. So I'll hold the low button down, turn the power on, it's a slave. This is also a slave because when I turn it on, kaboom, you get this fancy flashing pattern and the relays are taking their commands from the servo controller. So let's find a cable for that. Here's a cable, yet another standard cable. Let's plug that in and find another home for this. It doesn't matter where on the network it goes, as long as it goes. Hook it in there, and now when I fire a DCC accessory command, I move my servo and my corresponding polarity switch moves. Let's run that macro, move the lot. Almost musical. How simple and configurable is that? And I haven't touched a single programming tool. And by the way, yes, it's the same whether you have a mimic panel attached, a DCC module, or a DCC module and a mimic panel, and the relays and multiple servo controllers. They just plug in and they all work. Now if you're doing any work on your system under the baseboard, instead of temporarily wiring switches here because you might be using it on a network, we also have the PopOn config board. And if you just drop this onto the inputs where the switches are, as you can see I have none here, then as I operate each switch, you'll see I have control of 1 to 12. It's just like having 12 toggle switches attached. Not only that, but we've also replicated the 4 memories, so 1, 2, 3 and clear. So let's press memory 1, memory 2, clear it, and memory 3. So configured in one convenient little board is this little PopOn switch that has 12 toggle switches on it, or dip switches in this case, and the 4 push buttons. That's a nice convenience feature you can choose to have if you wish. So the next thing I hear you saying is, but Dave, I've mounted this unit under the baseboard and I can't get to it. Do I really have to crawl under my baseboards every time I want to press a button? No, of course not. We've got you covered. Here's a remote PopOn optional switch you can add, and it reproduces these 4 buttons here on the end of a 2-meter cable. Plug the device in, and now I can press the program button here, 1, 2, 3, 4, 5, 6, and turn that one, 7, 8, 9, 10, 11, 12, into a wild semaphore signal. I can do anything I want because I've now got all of these buttons in my hand at the end of a 2-meter cable. And you only need one for every layout if you don't want to crawl underneath. I'm going to set some of the global features on this board now, but before I do, let me remind you about the user guide that you can freely download from the product page on the shop. Everything I'm talking about on this video and demonstrating is covered by the user guide. So it shows you what's in the box, picture, how to hook it up. Come on, that's pretty straightforward, don't you think? There's even a picture of a switch, not a circuit diagram, an image of a servo plugged in, some power, and where and what all the buttons do. What the configuration buttons do at the bottom of the servo controller, and even programming and wiring details for the remote setup connector. It's all spelt out for you. We talk about how you install servos and what we recommend. We even have examples of how to mount them. We have an initial setup, plug it in, get it going, see it work. It discusses the master-slave pairing I showed you for the rhombus type fiddle yard. And it talks about different types of factory resets that I haven't shown you yet. And then into the reference, all the different modes I'm going to cover now. The board basically has 2 modes of operation. Master mode, where it's expecting to use a locally configured toggle switch here, and slave mode, where it's taking its instructions through the network. So let me show you how to change the modes. And what I'll do, I'll switch over to a servo controller that has some buttons attached as well. So what we're going to do now is I'm just going to operate the switch, and you can see that it's in master mode. Another way you can tell it's in master mode is when you turn it on, it immediately flashes the channel light and you get the regular heartbeat. If I want to set slave mode, all I do is I hold the low button, turn it on, and it goes into slave mode, and it'll select the last channel you configured, or the default, which is channel 2. The multi-panel is usually, or the other device is the first channel or the first device. Everything starts at 2 with a servo controller, so as you add them to the network it would be 2, 3, 4, 5, 6, all the way up to 17, which is 192 servos. When I turn the unit off and back on, you can see the lights are flashing again, and that's showing me I'm in slave mode. And if you saw after the alternate flash, it flashed out its channel number. Watch again. And we should see 2 flashes, 1, 2, indicating that this unit is on channel 2. Let's say you want to set the slave address and you want this to be address number 3 because there's already a device connected on address number 2. In the old-fashioned way, you'd attach some switches to the first 4 inputs And using this handy little chart in the user guide, you'd pick out the address you want by setting the switches. So by dropping the PopOn switch on and setting the switches in the right combination, with the first one is off, the second 3 are on and on. When I press and hold the low and prog button and turn the power on, it will now program slave mode address 3. 1, 2, 3 flashes. If I want to set the address to slave channel 4, then by toggling these switches, power off, press and hold low and prog, turn it on. And I'll get the next address, 1, 2, 3, 4. Well, that's great, but there's a much easier way of doing it. If you have a board from the middle of August 2018 and onwards, or the latest software update, you don't need that. All you have to do is have the unit in slave mode. Let's turn it on and see. Let's count the flashes for the channel. 1, 2, 3, 4. So this is configured to channel number 4. If I want to change it to channel number 5, whilst it's in slave mode, just press the high button. The unit, both lights come on, the unit restarts, and it's now gone on to channel 5. How simple is that? So we've done away with this. It's still a useful tool, but setting the address is so simple now. If I don't want 5, I'll press the low button and the address will now decrement. It'll come down one at a time. The board will restart. That's on 4. Let's go to 3. Hold it one more time. The board restarts and I'm on address 3. 1, 2, 3. How simple is that? Of course, it's really easy to toggle between master and slave modes. When I turn this board on, it's clearly in slave mode. All you've got to do to go to master mode, power off, press the high button, turn it on. Bang, it's now a master. Look, it's taking input from the switches. If I want to go back to slave, power off, press the low. Don't press low and prog because we don't want to teach it a new address. Just press the low, turn it on, and it's now back in slave mode at the previous address, which in this case is 2. If I want this to be address 3, press the high whilst it's in slave mode, hold it down for half a second, it restarts, and now I'm on address 3. So let's say you've been playing on the board, things are going great, you want to install it into your layout. Maybe you've made a right pig's ear of the program and you have no idea what's going on, it's just whatever you left it with. That's easy to get out of. There are 2 types of factory reset on this, one of which is very useful, one of which is less useful these days, and I'll show you why. Turn the power off, press and hold both middle buttons down, that's prog and high. Turn the power on, and you'll see the red light flash for about 5 seconds. It's doing a reset now, bang, and it's reset. Everything is default. All the servos will move about 90 degrees, and it's back in master mode. There they are, they're all moving. So if you make a dog's dinner of it, or you want to just simply reset it to how it was when you took it out of the box, press and hold both buttons. Now with the current factory reset, or the lab reset as the documentation refers to it, it will give you the 90 degrees of servo movement by default. And that's fine because the piano wire we advocate is flexible enough that if there's any extra movement here on your points, the piano wire will simply flex to absorb it. It's really straightforward. But if you're using a thicker piano wire or something that has no give, you're going to want to set the point motor output up on an individual basis so that you get just the right amount of motion. And it could be that this pushes too hard and starts binding. To do the old style safe reset, simply hold low and high and turn the power on. The unit will factory reset, but this time all the servos will go to the 45 degree, the midpoint position. This is the point where I usually get a phone call to say, the unit doesn't work. Actually, it's working perfectly. But in this reset, there is no movement configured here. It's all been taken out. So to add some movement now, because everything's in the center, it won't bind, you would go into program mode, and then you would add a little bit of movement. If I power cycle it, you'll see now channel 1 moves because I pressed the low and high buttons. Let's go back to the default. Press both middle buttons, turn it on, and we'll get the lab reset that gives us 90 degrees of motion. There we go. Life is good. For the next feature I need the scope. By default, when the servo controller is operated, we turn the pulses off. So here's a pulse and you can see it's growing as the servo moves, and then we turn it off. So you can see here, this is the pulse operating, and then after half a second it's disabled. And the width between the two is setting the angle of the servo, so you can actually see and visualize that pulse in real time. Now, for some obscure reason, you might want to turn the pulses back on. So that is possible, and the way you can do that is to press the high and the mode button whilst you turn the power on. And if you look at the LEDs, you get the red, then the amber, and it's now in a state where the pulse will always stay on, it'll never turn off. So that was the old mode, but it's there for backwards compatibility and in case you have a requirement where it must be on. In fact, if I show you semaphore mode, you'll see the pulse doesn't move as evenly as you would think. Check a look at this. There's the bounce, and here it is coming back. It's quite a fun thing to watch. But no matter what we do, the pulse for the whole 12 channels is permanently on. Now, if I turn the power off and hold the high and the mode buttons again, you'll see the red, the amber, the red and the amber. And what happens now is that the pulses get turned off, but this time you see there's 0 volts. Turn it on, pulse appears, and then it drops back to 0 volts. So when it's finished, the output to the servo goes to 0 volts. So you can set it pulses on, and that's always on, or pulses off with the line held low. And if I toggle it again, now when I operate, here we go, the board's rebooted, you'll see this time it'll be pulses off, but the line is held high, and that's the default mode because holding that line high is proven to be more robust for installation, but you're free to change it as you wish. Now, I promised you an undocumented feature as well, so here it is. Let me factory reset this board by holding both middle buttons and turning it on. And this time everything will reset. Great. So when the switch is in the down position, all of these servos are pointing away from each other, and when the switches are in the up position, they're in line. It's also possible to invert the switch logic so that you can reverse the way they work. And the way that's done is you turn it off, hold the mode button on its own, turn on, and see the lights go red to amber or right to left. Now everything is reversed. So I've effectively inverted the inputs to the switches, and that might be a useful feature that you need. Maybe you have a semaphore connected to a switch, it's going the wrong way round and it's easier to change that. Well, there you go. If I want it back again, it's easy. You simply hold the mode button again, and the lights will flash from left to right this time, and now we're back to normal. Now, when I said it was undocumented, it is documented, but no one sees it. There it is, mode. Inverts all switches. Well, hopefully you'll agree that there's quite a lot of features on this servo controller. There's a lot going on. It's a very powerful unit, and it's quite capable of controlling 12 servos on its own, or 12 servos connected via a network and integrated with other parts of your system, either via one of our beautifully made Mimic panels, or via a DCC handset, or even slaving from one unit to the other. I hope this has served as a refresher. I hope it directs you towards the documentation that lists all of these features, and I hope you enjoy using it, and thanks for buying it. Have a wonderful day.